Good day, Prof. This is the literature review section presented by the group forming by Yu Yifei, Zhang Tongtong, and Zhao Peizhu. So we selected the number 14 topic, the urban computing applications and planning related topics. And just a bit reason we select this is that we think this is the most relevant topic for us because there is a quite heated computer game called City Skylines, and when we try to be good at it, we should always considering the urban planning. And this topic is about planning from the macro perspective, such as the urban understanding and planning, to some operational aspects like the infrastructure, engineering, and the public utility operations. So now it comes to the topic of discovering functional regions of a city. We're just going to present 3 highly cited and representative papers of this field. And this topic indeed has some difficulties, such as difficulties in collecting POIs and vagueness of segmentation. But it is indeed for fields such as public operation and infrastructure planning. The first paper we're going to present is in 2012. They used the taxi traffic in Beijing and a document frequency method. They regard the mobility timely pattern as the vocabulary, and of course, the time slice of that vocabulary is word. And they try to classify the document as the functional region. They use a latent Dirichlet allocation method, which outperforms other frequency-based methods such as DF inverse, IDF, and DROF. And the second work relies on locality of user information instead of mobility patterns. They also use the document frequency method, but the word here is the POI with user patterns, and the document is the locality of functional regions, which consists of these POIs. And the third work tries to combine these 2 methods. They exploit the adjacency law of geographics and try to find the relationships between the interactions of POIs instead of absolute geographic locations. And we can see that indeed the functional regions can be mined with a variety range of data and techniques, which show the potential of this topic.
Hello, my name is Zhang Tong. Now let's talk about detecting vehicle illegal parking events using sharing-based trajectories. In this paper, the author proposed an approach to detect illegal parking events using sharing-based trajectories. By addressing the problem can enhance the traffic management and urban planning. The problem is addressed by pre-processing, which involves matching trajectories to road maps and building indexes, and also utilizing CAD tests to differentiate illegal parking events. The experiments are conducted by evaluating the effectiveness and the efficiency of the proposed system and studying the influence of the number of trajectories. The results show that the proposed system can detect illegal parking events effectively and provides reliable results. The limitation is that the system may not be able to capture the subtle differences between normal and affected trajectories, which can be mitigated by integrating with sensors or cameras. Alright, that's all about my part. Thank you. Alright, now let's move to urban computing with taxi cabs. In this paper, the author proposed an approach for the detection of flawed urban planning using GPS trajectories of taxi cabs. By addressing the problem can improve the efficiency and the effectiveness of transportation and resource allocation. The problem is addressed by modeling traffic based on taxi trajectories and regions, and also detecting flawed planning based on possibly flawed region and graph pattern many. The experiments are conducted by evaluating effectiveness of the ability to detect flawed planning, and also comparing the results with ground truth data to assess accuracy. The results show that the method successfully detects the flawed urban planning and correlation between unrelated flaws. However, the paper only considers the traffic and geometric features, which can be addressed by incorporating land use or population density.
I have reviewed two research papers focusing on bicycle sharing infrastructure development. The first paper emphasizes bicycle line planning based on shared bicycle strategy data, while the second paper addresses the challenges of collecting damaged shared bicycles. Both studies leverage shared transportation data to promote sustainable and eco-friendly commuting. The difficulty in bicycle line construction lies in balancing the total construction cost of the selected bicycle line within the budget while ensuring that these lines are interconnected to improve convenience and utilization. This NP-hard problem requires find a set of established road segments that overlap with the strategy and a continuous segment set to calculate the benefit score while adhering to budget and connectivity constraints. The greedy algorithms are used to solve this problem. After parameter analysis and data preprocessing, they find that the spatial clustering-based initialization method can prove accurate and effective result for bicycle line planning and its constraints. The limitation for this paper are that the path planning is not based on the behavioral strategies of all riders and has not been tested in real-world scenarios. The second paper discusses optimizing damaged bicycle collection route. It is also an anti-hard problem. It aims to minimize the labor hours cost through a double-layer compactive learning network while incorporating penalty coefficient for high time cost route. However, this study has its limitations, such as relying on a single data source for training and verification. The experiment design assumes that each damaged bicycle is parking in a fixed parking space. The both papers demonstrated the potential of leveraging shared transportation data for eco-friendly commuting infrastructure. Future research should explore a broader data source and real-world testing to overcome their limitation to enhance the further sustainable commuting solution.